Okay, so today we're going to look at a progressive wave. So what is a progressive wave? Now let us do a quick recall. Okay, so 10.1 is about progressive. Okay, progressive wave. Now, what does it mean by progressive wave? In previous chapter, the things that we have seen in a simple harmonic motion, which is a periodic motions, which means the object is moving back and forth or up and down. It keeps oscillating. Okay, back and forth, up and down, and it is a periodic motion, means it's going to keep moving between the two same position. So today we're going to look at progressive wave. It will give you a same graph. Okay, the difference would be, now in a progressive wave, it is actually a wave that is moving. But in simple harmonic motions, we just use a graph to represent the motion. So even though they have a similar graph, but actually they refers to two different type of motion. Chapter 9 is a simple harmonic motion. It is a periodic motion. In chapter 10, I would call it a wave motion. It tells you what happens to the wave. Now, what does it mean by wave motion? So when it comes to wave, a progressive wave, you need a source. Okay, so you drop something. Let's say now you have a water, so you drop something on it. Okay, so this source, it will start to generate the wave, okay, from this point onwards. So what is going to happen is, now you drop something onto the water and it carries energy. This energy will then be transferred into the particles next to it, and this particle will start to oscillate up and down. Okay, up and down or back and forth. So usually I will use up and down so it is easier for you to see. Okay, so it could be going back and forth as well, so it depends on the question. So in our case, we're going to focus on a progressive wave that is a moving oscillate up and down. All right, to make it easier for us to see. So it will transfer the energy to the particle next to it, and it start to oscillate. Okay, so initially, all these particles, they are lying on the same line. Okay, they are lying on the same line. So you drop the stone. Okay, you drop a stone onto the water. So what happened is, now, oops. Now the first stone, okay, the first stone, it transfer energy to the next particles. Okay, so it start to oscillate, and this energy is then being transferred to the following particles. So they are all going to oscillate. Okay, they are all going to oscillate, and eventually you will get a wave that looks like this. Okay, because all of them, they are oscillating at a different amplitude. All right, all of them, they are oscillating at a different amplitude. So eventually you will obtain a wave. So of course, it's not just moving on the one side, it's actually moving towards all direction. So it depends on the directions that we are taking. So in our case, in our syllabus, we are just going to focus on two direction. It's either to the left or to the right. Okay, so you drop a stone here, so it will generate wave. It will generate wave onto both directions actually, right? So in our case, we are just going to focus on just one direction. So maybe you drop a stone on the both end. So you have a wave. Okay, this is the first wave, I'm going to call it. So this is a wave that is moving to the right hand side. And this is another wave. Okay, this is another wave that is moving towards the left hand side. So in this case, we have a... Yes? Balkis, what is the questions? Oh, tak ada, tertekan. Okay, now, one wave going to the right and one wave going to the left. Okay, so what is going to happen right here is, now we are going to use different equations to represent it. So first of all, we have a wave of a y. Okay, this y, it represents the displacement of particles. Right, displacements of particles. Okay, so particle is moving up and down. So you're looking at what happened to just one particles along the same y direction. And then the x directions, okay, the x direction is either the times or the distance. All right, you can have an x or a t along the x direction. So I'm just going to use t first. Okay, you're looking at what happens to the time. So now I have one wave going to the left, and then I have another wave going to the right. Okay, so how am I going to know based on the equations where my object is going to the left or to the right, why the wave is going to the left or to the right? How do I know? Now it's based on the equations. If the wave is going to the right hand side, then we use the general equations y equals to a sine omega t minus kx. Okay, you use minus sign for object that is going to the right, for the wave that is going to the right, and then you use y equals to a sine omega t plus kx for the wave that is moving to the left-hand side. So left and right, they have a different equations. Okay, one is going to the left, one is going to the right. So that is how we know, that is how we tell whether my wave is moving to the left or to the right. So both of them, they must be moving towards opposite directions and then overlapping with each other in order to produce a stationary wave that we are going to look at in the following subtopic. So of course, this subtopic in this exercise one, we are going to focus on progressive wave first. Okay, what types of information that we can get from the graph, okay, and how to interpret the graph. So now we know what is progressive wave. We know how to determine the direction based on the equations given. How are we going to use these equations then? Okay, now we are going to see how to use these equations. What is the things that we need to substitute into these equations? The values that we need to put into these equations. So the general equations that we have is y equals to a sine omega t plus minus kx. Okay, I'm going to write it as a plus minus sign, as a general equations. So the values that we must substitute into this equation is a, omega, and k, because these three, they are constant. If you are looking at the same wave and there's no external factors that disturb the motion, then these three value, they should be constant. So a, omega, and k, they are constant. So you need to sub it into the equation. Okay, need to write the value into the equations. Okay, need to write the values into the equations. Now, when it comes to the other three terms, okay, we have another three, which is y, t, and x. So we don't have the value. So y, t, and x, because y changes with time and y also changes with displacement, therefore, this one, we leave it as unknown. Okay, leave it as unknown in our equations. So you have two different set of variables in an equations. One, you know the value. The other one, you don't know the value because it keeps changing. Now, what does it mean by changes with a t and x? Let's say now you have a y against t graph. Okay, at different time, these particles, it will have a different displacement because it keeps oscillating up and down. So initially, it is at its origin. Okay, and then after 1 second, maybe it moves slightly up because it's oscillating. After 2 seconds, it's at amplitude. And then after 3 seconds, now it drops a bit, it goes down a bit because it keeps oscillating up and down. So basically, you're just looking at what happens on the one particles. Okay, you look at what happens on this one particles, the wave, how it's oscillate. So basically, the idea is quite similar. Okay, when you have a y against t graph, the idea is quite similar to the simple harmonic motion because you're looking at the periodic motions of the particles. But now if you have a y against x graph, okay, you have a, let's say now you have a y against x graph. So basically the shape would be still the same, okay, but now you're looking at a different position. What is the displacement of the particles? Okay, you're looking at here now. So all particles, they will have a different displacement, okay, at a different distance. So y against x at a different distance, the particles will have a different displacement. So this is a y against x graph. So there are two types of graph that we're going to look at in this chapter. Okay, we're going to focus on this chapter. So y against t graph and y against x graph. So the information that we can obtain from a y against t graph is the period. Okay, time taken to complete one oscillation. So why is it important to have period? Because if you remember, period, omega, and frequency, they are one big family. So if you have a y against t graph, then it means you'll be able to determine the omega. All right. So if you have a y against x graph, then what is the information that you can get from here? Well, you will have lambda. Okay, you will obtain lambda. Now, what is the functions of lambda? Lambda and k, they are one big family. So if you have lambda, then you'll be able to determine the values of k. All right, so the information that you can get from the y against x graph is k. So of course, based on the equations given, of course, you have to know what is the information that you can get from the equations in order for you to put it into the graph. And that is our main focus today. We will go through a few questions on how to sketch graph based on the equations given. Okay, we're going to learn how to use these equations. So based on the equations given, we will learn how to plot the y against t graph, we will learn how to plot the y against x graph from the same equations. So the things that you have to remember, the things that you need to put in the equation is a, omega, and k, and the things that you need to include in your graph other than amplitude. Okay, if you have a y against t graph, then you need to insert the values of period. If you have a y against x graph, then you need to insert the values of wavelength, okay, the lambda, for one complete oscillation, one complete cycle. All right, so basically that is a quick summary for a progressive wave. We look at what happens to the equations, how to use the equations, how to interpret the equations, and also the graph. Okay, what is the things that we can get from the graph and how to form the equations based on the graph. So now let's go back to the questions. Okay, let's go back to the questions. All right, so oops. So what am I going to do right now? Okay, we will go through the equations, okay, one by one. Okay, whenever you're given some equations, what are you going to do? So a progressive wave is described as y equals to 2 sine bracket 2 pi and then open bracket again t over 0.4 plus x over 80, where x and y, they are in cm. So again, you have x and y and it tells you what is the unit. Okay, so other than y, you need to mention the unit for x and as well. Why? Because, okay, that is because for x, okay, you use x to determine the unit for k and also lambda. Whereas for y, we use it to determine the unit for amplitude. So when it comes to this subtopic, you need to mention what is the unit for x and y. They might have different unit, okay? Not always have the same unit. X and y, they could have different unit. Maybe x is in terms of meter and y is in terms of cm. That can happen, all right? But how do we know which one to use? You look at the informations given. If you are given amplitude, then you know the amplitude should be in cm. Okay, it should follow the units of a y. So if you want to determine the unit for a k, if the question asks you to determine k, then you need to know that the unit, okay, it has the same unit as your x, okay, as x. So if x is in meter, then k and also lambda should be in meter as well. Okay, k is meter -1, lambda is meter. All right. So whereas t is in second, so t, we use it to determine the unit for omega and also period. So if it is in second, then for omega, you have radian per second. If it is in minute, then for radian, the unit would be in radian per minute. Okay, for omega, the unit would be in radian per minute. So it is quite important for you to know which unit to use. Okay, which unit to use. So determine the following from this wave. Now you are given an equations y equals to 2 sine and then 2 pi t over 0.4 plus x over 80. The first things that you should do, okay, the first things that you need to do is to write down the general equation. So what is the general equation? So general equation is y equals to a sine bracket. Okay, now what am I going to do right now? Okay, I have omega t, and then you check the sign conventions in the equation. In this equation, it gives you plus. So in our general equation, we're going to select plus sign. Okay, we're going to use plus sign in our general equation. So plus, oops, kx. Okay, plus kx. So by comparisons, we then obtain a is equals to 2. So what is the unit? Now, because my y is in cm, so a is equals to 2 cm. All right, it follows the unit of your y, your displacement. So when it comes to this equation, y is displacement. Okay, don't get confused. Y represent the displacement of particles. And then x represent the distance of the wave. Okay, the distance traveled by wave. So there are two different things. So don't get confused. One is distance, one is displacement. Okay, so you look at the question. Sometimes questions might ask you to calculate displacement. Sometimes questions might ask you to calculate the distance. So you need to know which one. Okay, you need to know distance is which one, displacement is which one. Okay, now questions 2. Questions 2, the wavelength. Question asks you to calculate wavelength. If you recall the things that I just told you, wavelength and K, they are one family. Okay, wavelength and K, they are one family. So if you want to find if you want to determine the values of wavelength, then you need to have K. So do you have K? Of course you have. By comparison, now one things you have to be extra careful. The equations given, they put 2 pi outside the bracket. Okay, they put 2 pi outside the bracket. Now what does it mean? Actually, this 2 pi, it should be included in the omega, and it should also be included in your K. So which means by comparison, K is not equals to 1 over 80, but it is equals to 2 pi over 80. Okay, K is equals to 2 pi over 80. And now what is the relationship between K and also a lambda? Now K at the same time is also equals to 2 pi over lambda. So when you combine these two equations, what does it mean? It means you have 2 pi over 80 equals to 2 pi over lambda. So lambda is then equals to 80. So what is the unit? Well, again, you look at the unit for x. So x is in cm. Therefore, lambda should be in cm. Okay, lambda should be in cm. Oh yeah, now just now I say k is equals to 2 pi over 80. So what is the unit? So unit for k is also cm, but it comes with a -1. Okay, cm -1. So that is the unit for k. So lambda is in terms of cm. So lambda equals to 80 cm. So that is your questions number 2. Now, questions number 3. Questions now wants frequency. Okay, questions 1 and frequency right now. So frequency, again, if you recall the things that I keep telling you guys, frequency, omega, and period, they are one big family. If you want to determine the values of frequency, then you need either the omega or the period. So by comparisons, we can obtain omega from the equations. So omega is equals to, okay, not 1 over 0.4, but it is 2 pi over 0.4. Okay, 2 pi over 0.4 radian per second. So what is the relationship between omega and frequency then? Now, omega is also equals to 2 pi f. So by comparisons, again, when you combine these two equations, you have 2 pi over 0.4 equals to 2 pi f. Rearrange equations, you will obtain f equals to 2.5 hertz. So that is the answer for questions number 3. Okay, now questions number 4. Questions number 4, okay, you have to be extra careful. Now, because it is asking for speed of what? Speed of wave. It is not asking for the speed of particles. If it is asking for speed of particles, then you need to use simple harmonic motions to solve it, because your particle is moving in periodic motion. Okay? So you have simple harmonic motion inside wave motion. Every particles, they are moving in their own simple harmonic motions. When you join them together, they becomes a wave motion. All right. So this question now is asking for wave speed. It is not asking for speed of particles. So make sure you use the right equations. Wave speed, we have one general equation, which is V equals to F lambda. Okay. So if it is asking for particles or speed of particles, then how are you going to solve it? That would be in the next question. Okay, questions B, we will look at speed of particles. So right now, you're looking at wave speed. General equation for wave speed is V equals to F lambda. So questions 3, you calculate F. Questions 2, you calculate lambda. Straight away, you will be able to obtain the values for V. So F is 2.5, and then lambda is 80 cm. So your V should be in cm, all right? So it is equals to 200 cm as -1. Now, can you use meter? Of course you can. If you use meter, then the answer would be 2 meter per second. Okay, 2 meter per second. So that is questions 1A for you. All right, so questions 1A, now I give you 2 minutes to write it down, okay? Because this is a quick revisions. We include the quick revisions here. So I give you a few minutes to write it down. You can write down the things that you think you need to write down, you need to record, right? So kamu boleh catat lah yang kamu rasa penting, yang kamu rasa tak faham. So a few minutes for you to write it down. Okay, so this is a quick revisions on how to use the equations. What is the information that we can get from the equations and how to solve it? Okay, how to solve it. Okay, kalau ada soalan boleh tanya ya, because this is still in the basic. Okay, we are still learning the basic of a progressive wave, just the equations. So kalau equations anda tak faham, nanti bila kita nak buat sketching, anda akan lagi pening. Okay, lagi pening. All right, one more minute for you to write it down. If you have any questions, you may ask.
Madam,
Yep.
I just want to confirm that soalan frekuensi tu yang 3 tu, to get 2.5 tu 1 bahagi 0.4 kan?
Yeah.
Okay. Thank you.
All right. Okay, so questions 3, basically you just cancel the 2 pi, right? So ini adalah, okay, this is actually 2 pi f over 1. So you cancel out 2 pi, this one f divided by 1, you obtain f, and then this one it becomes 1 over 0.4. Okay, dia menjadi 1 per 0.4. So you cancel it out. Okay. All right, now questions B. Questions B now, this is for displacement, okay, the displacements of a particles. So you want to determine the maximum value of dy over dt at x equals to 0. So this statement itself, actually it tells you it wants 2 different things. Okay, so based on just this statement, actually it's asking for 2 different things. So what is the things that you need to do? First thing, you need to find out what is the value. Okay, what is the value for dx over dt? Okay, dx over dt at x equals to 0. So that is the first thing that we need to know. So this would be our step 1. Okay, our step 1. And then, okay, and then we want to find out what is the maximum value after you complete step 1, after you manage to determine the values of dy over dt at x equals to 0. So this is our step number 2. Right? Kita ada step pertama, kita ada oops. Ya. Okay, so we have a step number 1 and also step number 2 here. So what are we going to do right now? We need to differentiate the equations. So you are given, okay, let's go back to step number 1. We want to determine the values of dy over dt at x equals to 0 first. So step 1. Okay, step 1, we have y equals to 2 sine, okay, 2 sine, okay, I'm just going to write it as a whole, 2 pi over 0.4t plus 2 pi over 80x. So this is the equations given. So what we want to do right now, we need to differentiate this equation. Now, of course, if you think it is very hard for you to differentiate the equations in terms of a value, with value, you can always differentiate the general equation. Okay, so you have y equals to 2 sine 2 pi over 0.40 plus 2 pi over 80x. So this is actually coming from y equals to a sine omega t plus kx. So you want to differentiate with respect to time, because according to the questions, you need dy over dt. You want to differentiate with respect to time. So dy over dt is then equals to 2. Now, because you want to derive it with respect to time, so we take the values of omega out. Okay, we put it at the front. So you don't need to include 2 pi over 80. So 2 pi bracket 2 pi over 0.4. Okay, so a sine become cos after you differentiate it. Cos and then 2 pi over 0.4t plus 2 pi over 80x. So if you differentiate it in terms of equation, then what is going to happen? Basically, you're just going to obtain y equals to a. Now, because you want to differentiate with respect to time, so you differentiate omega t. Therefore, you obtain omega here. So a omega, this is dy over dt. So a omega, and then sine become cos omega t plus kx. So if question asks you to differentiate, okay, I'm just going to rewrite first. Now, if question asks you to differentiate with respect to distance, okay, so if question asks you to differentiate dy over dx, then you're going to obtain a, and then you differentiate kx. So it becomes ak cos omega t plus kx. So it depends on you differentiate with respect to what. If you differentiate with respect to time, okay, kalau kamu differentiate with respect to time, then you need to differentiate omega t. If you want to differentiate with respect to distance, then you differentiate the one with x. All right, but now because question is asking for dy over dt, so we don't want this one. Okay, kita tak nak yang ini. Sebab soalan minta differentiate with respect to time. So dy over dt equals to 2 pi over 0.4 cos 2 pi 0.4t plus 2 pi over 80x. Now at x equals to 0, so this is what we want to do. At x equals to 0, so you sub the value 0 into the equation. Eventually, you will obtain, okay, dy over dt equals to 10 pi and then cos, okay, cos what? Now, cos bracket 2 pi over 0.4t. Okay, so now because you sub x equals to 0, therefore this whole thing becomes 0, okay, because of x equals to 0. So now we have dy over dt equals to 10 pi cos 2 pi over 0.4t at x equals to 0. So that is our step number 1. Okay, that is our step number 1. So now let's look at step number 2. Okay, so step 2. So what happened at maximum value? Okay, so whenever question asking for maximum value or minimum value, the place that we can play with, okay, that we can change it is the part with a cos or a sine function. So at maximum, okay, at maximum, cos 2 pi over 0.4t it is always equals to 1. It doesn't matter what is the value inside the bracket. Okay, it doesn't matter what is the value inside the bracket. As long as you have a cost function here, then we always say cos theta equals to 1 at maximum. Okay, at maximum. So even if you have a sine function, okay, we can also say sine theta is equals to 1 at maximum value. So whenever you're given a trigo function and question is asking for maximum value, your assumption would be the whole thing, the cos function or the sine function is equals to 1. If it is asking for minimum value, then you say it is equals to 0. All right, so that is the things that you have to know. You're going to use it until SEM 2. Okay, whenever you have a cos or a sine in an equation, the things that you need to know is they are always equals to 1. So since cos 2 pi over 0.40 is equals to 1, therefore, okay, I'm going to say V maximum. So why V maximum? Because dy over dt, it is actually your velocity. Velocity of particles, okay, the speed of particles. So the maximum speed of particles, it is just equals to 10 pi. Okay, so 10 pi what? What is the unit? So 10 pi cm as negative 1. Okay, cm as negative 1. How do I know it's a cm? Because my y is equals to 2 sine. This 2 is in terms of cm. Okay, therefore, because I differentiate from y, I obtain v, so the unit for v should also be in cm. Okay, it should be in cm. That is because of the amplitude given in the y. So if amplitude in y is in terms of meter, then your velocity would be meter per second. All right, it would be meter per second. So this is how you solve it. Okay, so step number 1, you determine the value for x equals to 0. Okay, at x equals to 0. And then step number 2, once you have the equations, you then try to identify what happened at maximum. So at maximum, it doesn't matter what is inside the bracket, as long as you have a cos function or a sine function, then we always assume it is equals to 1. And if the question is asking for minimum, then we say, okay, if question is asking for minimum, then we say sine theta and also cos theta, both of them, they are equals to 0 at minimum, right? At minimum. So this is another set of value that you need to know. So maximum and minimum, they have their own values already. It's fixed. You don't even have to calculate it. Okay, it's either 1 or 0 between maximum and minimum when it comes to a trigo function. All right. So this question is a slightly more complicated. I give you more time to write it down. Okay, 5 minutes for you to write it down, including try to understand the whole equations, including try to understand how to do the differentiations. Okay, and you have 2 steps here. Why 2 steps? That is because of the questions tells you maximum value of dy over dt at x equals to 0. Actually, to be more precise, you can split it into 3 steps. Okay, which 3? So step 1, you calculate, you differentiate first dy over dt. And then step 2, you find out what is the value at x equals to 0. And then step number 3, what happened at maximum? Okay, what happened at maximum? So this is how we solve it. So 5 minutes for you to write it down, including all the differentiations, including what happens in every step. Okay, and remember this value, okay, what does this value refers to? This value refers to maximum speed of what? Of the particles. Okay, of the particles. Because you are looking at y, okay? So y is all about particles. So dy over dt, it is the speed of particles. In previous question, we have speed of wave. So now you see the difference. Speed of wave is just v equals to f lambda. Speed of particle is dy over dt. Okay? So 5 minutes for you to write it down before we proceed to next questions.
Madam,
Yep.
can I ask, kenapa yang kita macam maximum dengan minimum value tu, 1 dengan 0, kita ambil daripada graf ke?
memang daripada graph. Even kamu tekan calculator pun, maximum value yang kamu boleh dapat dari 0 degree sampai 360 degree adalah 1.
Oh, kalau macam minimum lah kan.
Aha.
Kenapa
Kalau
macam
minimum memang kosong lah.
bagus lah, bukan negatif 1 ke?
Tak ada, kita ambil kosong. Sebab biasanya kita either looking at 1 or 0.
0. So kalau macam contohlah soalan ni kata kan, at minimum value. So kita punya V minimum mesti kosong lah.
Ya, V minimum mesti kosong. Sebab dia bila when it comes to V, the negative just indicate the direction. Dia bukan indicate the magnitude. So negative cuma bermaksud dia menghala ke arah negatif. Tapi nilai dia masih maksimum, which is 1.
Okay, thank you madam.
Alright. Okay, so if you're done, you may try questions 2A. So 2A, it tests whether you understand the whole equations or not. Okay, because it wants you to identify all F, omega, period, and everything from just one equations. Okay, so you can try 2A first if you're done. So I give you 2 minutes to try. Okay, try questions A. See whether you understand the equations or not. Okay, so now let's see how to solve questions 2. So a progressive wave is represented by the equations y equals to 5 sine 2 pi t minus pi over 2x. So these equations, okay, this is equations given, and this is a progressive wave equations. So whenever you're given an equations, remember the first things that you should do, even though the question didn't ask you to do, is to do the comparisons. Compare with general equations. So y equals to 5 sine 2 pi minus pi over 2x. This equation is y equals to a sine omega t now, because equations give you negative, so you keep the negative sign in your general equations. So negative kx. So determines the amplitude, the angular frequency, wavelengths, period, frequency, wave speed, and the directions of motion based on these equations given. So this question, it truly tests your understandings on the equations, whether you understand these equations well enough or not. So it's asking for how many things? Now let's see. 1, 2, 3, 4, 5, 6, 7. There are 7 types of informations can be obtained from just one equations. Okay, so now let's see how to solve it. So questions 1, the amplitude. So amplitude, by comparisons, my A is equals to 5. So what is the unit? Now, according to questions, X and Y, they are both in cm. Therefore, A is equals to 5 cm. Okay, A is equals to 5 cm. Now, questions 2. Question asks you to determine the angular frequency. So by comparisons, omega, okay, so omega, which part of the equations? So by comparisons, my omega is the part in front of t. So it is equals to 2 pi. So 2 pi radian as -1, because time is in second. Okay, time is in second. And then questions number 3, wavelength. So how to determine wavelength? If you remember, wavelength and K, they are one family. Okay, wavelength and K, they are one family. So in order to determine the values of wavelengths, we can try to identify the values of K first. So by comparison, now I have K is equals to pi over 2. Okay, K is equals to pi over 2. So what is the unit? My X is in terms of cm. Therefore, cm -1. So compare with the general equations for K, which is K equals to 2 pi over lambda. Okay, by comparisons, I have 2 pi over 2 equals to 2 pi over lambda. Okay, so lambda is then equals to, oh, sorry, it's just pi over 2, not 2 pi over 2. Okay, so lambda is then equals to 4 cm. Okay, 4 cm. So this is by comparisons. Very simple. Okay, very simple. So lambda equals to 4 cm, because my K is cm -1. So remember how to determine the unit. You look at the unit for K. Okay, you look at the unit for K. So K is cm -1. Therefore, lambda is cm. Okay, lambda is cm. So we are done with the third questions, wavelength. Now questions number 4, period. So how to calculate period? Well, period, omega, and frequency, they are one family. So if I want to calculate period, I use omega, which is 2 pi radian per second. So what is the relationship between omega and period? Omega equals to 2 pi over t. Okay, so given omega is equals to 2 pi, therefore 2 pi over t is equals to 2 pi, and period is then equals to 1 second. Okay, 1 second. And then questions number 5, frequency. So T, omega, and F, they are one family. So you want to calculate frequency? Well, the easiest way is to use F equals to 1 over T, which is then equals to 1 over 1, which is equals to 1 hertz. Okay, 1 hertz. So very simple. And then questions number 6, wave speed. Again, you are looking at wave speed, the speed of wave. So V is equals to F lambda. This is the general equations. So F given is 1, and then lambda is 4. So I have 4. So what is the unit? Because my lambda is in terms of cm, therefore it's 4 cm as -1. Okay, 4 cm as -1. And then how about the direction? Well, because you have a negative sign in your equation. Okay, if you remember, negative means to the right. This is just for the wave motion, okay, for wave motion. So negative in equations means to the right, positive means to the left. Therefore, according to the equations given, you have a negative sign here. So the answer is to the right. Okay, the answer is to the right because of negative sign. So now that you have the answer for all 7 questions. So basically, these are all of the informations that you can obtain from just one equations. Okay, from just the equation itself. So now I give you 2 minutes to write it down, and then we will proceed to graph sketching. Okay, kita akan belajar sketch graph. So 2 minit bagi anda catat. Okay, 2 minit bagi anda catat.
Madam, just
Yeah.
asking. Kenapa dia ada macam yang X dengan T kat tepi Y tu?
Dia ada
X dan T tepi Y.
sebab Y dia boleh depends on T, dia boleh depends on X. It actually depends on 2 things.
Dia cuma nak macam habak benda tu lah kat situ.
Pada equations itu, okay, this whole equation actually dia beritahu anda kamu punya Y dia bergantung pada 2 benda. Dia either bergantung pada T atau dia bergantung pada T dan juga bergantung pada X. At different time and different distance, you have a different values of Y. Y changes with X, Y changes with time. Itu maksud dia.
Okay, faham. Thank you, madam.
Okay.
Madam, kiranya yang X dengan T tu bukan exist lah.
Dia adalah exist kita, cuma kita kena pilih. Tengok soalan minta kita sketch Y against T graph ke atau Y against X graph.
Okay.
Okay, so let us look at graph sketching. So dari graph anda boleh nampak lagi jelas kenapa kita ada X dengan T di dalam satu equations. Okay. So questions B. Okay, sketch the graph of sketch the displacement. Okay, the displacement against distance graph. So you look at the questions will tell you what types of graph you need to sketch. So according to this question, it is asking for Y against X graph. For a progressive wave above in a range, so you are given a range in between 0 until 2 lambda. Now, why is it important to know the range? Because it tells you how many cycles you need to include in your diagram. So for this question, it wants you to sketch the graph for 2 complete oscillation, 2 cycle. Okay, because 2 lambda. At times t equals to 0. Okay, so at times t equals to 0, you look at the motions of that one particular particles. See what is the shape, okay? What is the shape of the graph, okay? So see what happens, what is the displacement of the particles at a different position, at a different distance. So now sketch a graph of y against distance graph for a progressive wave above in a range. So if question asks you to sketch y against x graph, then t will be given. Okay, so t is given in a y against x graph. If question asks you to sketch y against x graph, then you need the values of t. So given the general equation, okay, we have general equations y equals to 5 sine 2 pi t minus pi over 2x. Okay, 5 sine 2 pi t minus pi over 2x. So you have x equals to, you have t equals to 0, sorry. So at t equals to 0, so you're looking at what happened to the wave. Okay, what is the shape of the wave at times t equals to 0? So at times t equals to 0, I have a graph y equals to 5 sine. Okay, now you have 2 pi t, t is 0. Therefore, you are left with just negative pi over 2x. Okay, negative pi over 2x. So this negative, we cannot leave it in the bracket. We need to take it out. So you take it out, it becomes y equals to negative 5 sine pi over 2x. So this is the equations that we have. All right, so the things that you need to know, okay, this is an extra information for you guys. If you have a cos negative theta, then it is equals to cos theta. But if you have a sine negative theta, then it is negative sine theta. Okay, so this is the rules from mathematics. So you need to know these rules. So now you have a negative inside the bracket, so you take it out, and it is a sine function, so it becomes negative sine. So negative 5 sine pi over 2x. So how are we going to sketch this graph? Very simple. If you look at this graph, now it's very similar to the simple harmonic motion graph. Okay, so you don't have initial phase angles, you just have the 5 sine. Okay, so step number 1, I'm going to sketch the axis for it. According to questions, I need to sketch y against x graph. So my y is in terms of cm, my x is also in terms of cm. Okay, so at times t equals to 0, I have a graph of negative sign. So negative sign is inverted sine function. So terbalikan sign punya graph. And according to question, because the question is asking for the distance between 0 until 2 lambda, I need to sketch 2 complete cycle. Okay, I need to sketch 2 complete cycle. If you stop at 1, then it's wrong. Okay, if you have more than 2, then it's also considered as wrong, because question is asking for in between 0 until 2 lambda. All right, so this is a 0, and then this is lambda. Now lambda, I have value equals to a 4, so 2 lambda equals to 8. So label at lambda. Okay, label at lambda and 2 lambda, the positions. This is the things that you need to include in your graph. And then amplitude is 5, and here is negative 5. Okay, here is negative 5. So step 1, you sketch the axis. Step 2, you label it. Okay, you sketch the graph first. Okay, you sketch the shape first, and then step number 3, you label the graph. So this is the complete answer. Okay, this is the complete answer for these questions. Okay, now the things that you know, okay, if you look at this equation, y equals to negative 5 sine pi over 2x. Just now you asked me why you have a x and a t in the same equations. So because it depends on both things. So at times t equals to 0, this is the shape of the graph. At different distance, every particles, they have different displacement. And if you know the values of x, for example, you take x equals to 4, then you will know what happens to that particular particles in the wave motion. So for the wave, okay, for this wave, okay, for a wave, it consists of a lot of particles. By knowing the informations of t and also x, then you will know which particles the question is talking about. Okay, and the shape given right here is the shape of the wave at times t equals to 0. This still consists of many of particles, okay, many particles. But if you are given the values of t and also the values of x, then you will know exactly what happens to that one particular particles. Alright? So, asalnya kamu ada satu wave yang terdiri daripada banyak partikel seperti dalam kotak ini, okay, yang saya tunjuk dalam kotak ini. So, kalau kamu diberi T, dia bagi kamu shape of the wave pada certain waktu, okay, pada certain masa, at a particular time. Tapi kalau dia bagi lagi informasi berkenaan dengan X, then kamu akan tahu, oh, manakah particles yang dia tengah tengok. Okay, which particles the question is talking about. So if you have the T, then you just have the general shape. If you have both piece of information, then you know which particles that you need to look at, you're looking at, okay, you're dealing with. So kalau soalan bagi kamu X dulu, then it tells you what happens to the shape at that particular distance. Okay, at the particular distance, dia punya particles oscillate dalam bentuk apa. So if you are given both piece of information, then again you need you will get the information about that particular particles at a particular time. Okay, so sekarang kita tengok Y against X dulu. Okay, Y against X dulu. So pada T sama dengan kosong, inilah bentuk semua particles punya gerakan. Okay, semua particles punya bentuk. So kalau dibagi X lagi, nanti kamu akan tahu particle mana yang kamu tengah tengok. So after this, we will look at the equation. We will look at Y against T graph, and that one I will tell you what happens again. Okay, based on the graph. So kenapa kita ada dua maklumat di dalam satu equations? Sebab Anda memerlukan dua maklumat untuk identify particle yang mana satu yang Anda tengah tengok. Because wave consists of more than one particles. Without T and without X, you don't know which particles you are looking at. But if you are given times, then you have the shape at that particular time. Okay, you have the distance or you have the displacements of all particles at that particular time. So this is the meanings of Y against X graph. So jelas kah? Boleh faham kan? Setakat ini.
Madam,
Boleh,
yang
madam.
4 tu,
Aha.
yang 4 tu satu darab dengan apa tu lambda kan? Satu darab 4 kan?
Ya.
Dapat 4
Ya.
kan? Okay.
Ya.
But
Sebab
one
4 ini
cycle.
4 ini one cycle, dia berlaku pada 1 lambda. So this is a 1 lambda. So untuk 8, this is actually 2 lambda.
Okay.
So tadi ada siapa lagi yang nak tanya soalan? Tak ada. Alright, so bagi anda 5 minit untuk catat dan juga cuba. Okay, I want you to try questions D. Okay, questions D. Kita skip C dulu. Kita pergi kepada D dulu. So now I want you to try questions D. Questions D is very similar to this question, but now the question is asking for displacement against time graph. So kita dah siap dengan displacement distance graph. Sekarang kita tengok displacement time graph dulu. Right? So I give you 5 minutes. You write down this one and also try question D. Soalan D lebih kurang sama saja. Pastikan Anda cuba. Okay, jangan tunggu. Okay, so now let's go through questions D together. So questions D, if you look at the questions, now question is asking for displacement against times graph. It's asking for Y against T graph. And if the question is asking for Y against T graph, then displacement is given. Okay, so displacement, oh, sorry, not displacement, sorry, distance is given. So distance is given. Okay, is given in a Y against T graph. So this is the things that you need to know. If question asks you to sketch Y against X graph, then times will be given. If question asks you to sketch Y against T graph, then X will be given. Okay. And then if you look at the question, now it's asking for a range of 0 until 2t. So again, it is asking for 2 cycle, 2 complete oscillation. Okay, so now let's see. At the general equation first. So the equation given is y equals to 5 sine 2 pi t minus pi over 2x. So this is the equations given. So at x equals to 0, I have equations y equals to 5 sine 2 pi t. Now, if you look at this equation, now you're left with just 2 unknown, which tells you now your y, the displacement of the particle, it changes with time. So now it gives you the distance. It tells you to select which particles already, but this particle is still oscillating. So the displacement of the particles, now you know which particle, but you don't know the exact positions yet because it changes with time. So if you're given the times again, then you'll be able to identify the positions of that particular displacement, of that particular particles at that particular moment. Okay, the positions of that particular particles at the particular moment. So if you are given both x and t, if you are given t, you are just having the amplitude of all particles at that particular moment. But if you are given distance, then it tells you which particles already, the particle at which positions already. But since the particle is still oscillating, it still changes with time. So you don't know where is it yet. Okay, you don't know where is the exact locations of that particles yet. So these are the meanings of the equations. So you need both pieces of information in order to identify, okay, to identify the displacement of the particles. So now you have y against t graph. Let's sketch the axis as usual. So y in terms of cm and t in terms of second. If you look at this equation, now this equation is very similar to simple harmonic motions, and in fact, it is simple harmonic motion equations. Why? Because the particles is moving in a periodic motion, like I told you just now. The particle is oscillating, okay, up and down. So it is a periodic motion. It is oscillating in between amplitude and negative amplitude. So this is in fact a simple harmonic motions equations. So now if you look at this equation, there's no initial phase angle. So it means at x equals to 0, your particle is located at 0. Okay, it's located at 0. So now what we want to do, we want to sketch the shape of the graph, okay, the motions of these particles. So it changes with time. At different time, it will have a different shape. So y equals to 5 sine 2 pi t without initial phase angle. It means my object starts from 0. So at times t equals to 0, my object starts from 0, and it is a sine function. So I'm just going to sketch a sine graph. But again, if you look at question is asking for 2t, 2 cycle, you need to add one more cycle. Okay, you need to add one more cycle. So you cannot have more than 2, you cannot have less than 2. So now that you have the shape, you have the axis, remember to label the amplitude. Okay, and also the period. So this is 0, this is -5, and periods given just now is a 1 second. So 2t is 2 seconds. All right, so this is 1t. And then from here until here, this is 2t. Okay, that's why you have 1 second and 2 seconds. So 2 cycle. So now we answer the question, and that is the answer for questions D. Very similar to questions B. The difference is the x-axis. Okay, just now we have y against x. Now we have y against t. All right, so this is your questions D. Okay, questions D. So I give you 2 minutes to write it down. Then we will go back to question C. Okay, question C is a question with initial phase angle. So if you are done, of course you can try first. Okay, kalau dah siap, anda actually boleh cuba dulu soalan C. Tengok macam mana anda nak selesaikan dia. All right. So this is just a very simple question. If you understand B, then you should be able to do D. Now let's see. Question C. So question C, now it wants you to repeat questions B. So what is the questions B again? Questions B asks you to sketch displacement distance graph. Okay, so according to questions B, okay, you need a y against x graph for the range in between 0 until 2 lambda. Okay, where you have 0, x, and 2 lambda. But now the difference is time is no longer at t equals to 0, but it is equals to t equals to 0.25 capital letter T, which is your period. So now at t equals to 0.25 t, now you need to know what is the value first. So it is equals to 0.25 times 1, because given capital letter T is equals to 1 second, according to the equations above. Okay, according to these equations, y equals to 5 sine and then 2 pi t minus pi over 2x. Okay, just now in questions A, we managed to calculate the values of period, which is equal to 1 second. So at t equals to 0.5 capital letter T, so small letter t is still equals to 0.25 second. Okay, 0.25 second. So you sub the value. You just sub the values of period into this equation, okay, into this relationship. So at times t equals to 0.25 second, what do we have? So now we have y equals to 5 sine, okay, 5 sine what? 5 sine bracket 2 pi, okay, this is 0.25 and then minus pi over 2x. Okay, so it is equals to 5 sine bracket. Now 2 pi times 0.25. 0.25 is actually 1 over 4. So you obtain 1 over 2 pi. Okay, 1 over 2 pi minus pi over 2x. So if you want to plot the graph, you need to make sure the unknown is at the front, okay, not at the back. So you need to rearrange the equations. So how to rearrange the equations? So rearrange it, you will then obtain y equals to 5 sine, 5 sine, and then a bracket, negative pi over 2x. You need to make sure the x is at the front. So plus 1 over 2 pi. Okay, plus 1 over 2 pi. Now, how to simplify this equation? Your x now is at its correct position, but if you look at the equation, you have a negative sign there. Like I told you, you cannot have a negative sign in trigo functions, right? So what should you do? So we are going to take this negative out. So sine negative, so you take this negative out, what are you going to get? You will have y equals to negative 5 sine bracket pi over 2x minus 1 over 2 pi. So you factorize the negative out. Okay, so this is the equations that you have right now. All right, so this is the equations that we're going to use to plot the graph. Okay, to plot the graph. And if you notice, now I have a quite complicated equations. I have an equations with a negative sign, a negative initial phase angle. So what should I do? So I'm going to show you step by step until you get the final shape. Okay, until you get the final shape. So what am I going to do right now? I'm going to split the graph into 3 sections. Okay, I'm going to split it into 3 steps. So step 1. Step 1, I would like to sketch a graph for a general shape, okay, for a general sine function first. So let's say now I'm going to sketch a graph for a and y equals to a sine kx first, okay, y equals to a sine kx without initial phase angle first. I'm going to obtain the initial shape of the graph first. So now this is my y against x graph. Okay, saya dapat bentuk asas untuk sine dulu before I shift the graph. So y against x, cm, and then cm here. So given sine, okay, given sine function, so what am I going to do? I'm just going to give it a sine shape, okay, the shape of the sine. So the shape of the sine. So this is a step number 1. If you have an equations without initial phase angle. So since now you have an equations with initial phase angle, then what are you going to do? Now I'm going to move on to step number 2. Okay, step number 2. Step number 2, now I have negative initial phase angle. So y equals to a sine kx minus 1 over 2 pi. Okay, so 1 over 2 pi is how many cycles? Try to ask yourself. So 2 pi is 1 cycle, pi is half cycle. So half of the half is 1 over 4th cycle. Okay, or in another words, it represents 90 degree. So negative 90 degree, you start from a negative 90 degree. So you have a negative sign here. What are you going to do? You are going to shift the y-axis to the left. Okay, you shift y-axis to the left. All right. Or you can say you move the graph to the right. But if you move the graph to the right, then I think it will be a bit complicated. Okay, actually this whole graph, you can move it to the right because negative sign means your graph is moving to the right by 90 degrees. So usually I would like to shift the y-axis. Okay, shift it by 90 degrees. So after I shift it, what am I going to get? Okay, so this is the graph. So y against x graph, after I shift it by 90 degrees, so my graph would now start from negative here. Okay, negative amplitude, which makes sense because in a simple harmonic motion, we say this negative pi over 2, it starts from 270 degree. Kalau kamu ada satu circular motion, it's actually start from, okay, this is your origin, so it start from here. Okay, it start from negative pi over 2 here. So this is your negative pi over 2. So objects start from negative amplitude. Okay, so negative amplitude, now I have a graph like this. Okay, I have a graph like this. Right, this is the shape of the graph. When I have an initial phase angle which is equals to negative pi over 2. Right, so this is my A. And now, if you look at the equations, other than initial phase angle, I have a negative sign in front of 5. So what am I going to do? Okay, what am I going to do? So now I'm going to do step number 3. I'm going to add one more step. So step 1, I sketch the basic shape first. Step number 2, I see whether I should shift the graph. Okay, I should shift the y-axis to the right or to the left. Okay, you can choose to shift the whole graph. Okay, kamu boleh pilih untuk shift graph ini. Tetapi kalau saya lebih suka shift y-axis to the left or to the right. So step number 3. Okay, because of this negative sign, now I have y equals to negative a sine kx minus 1 over 2 pi. Okay, I have negative. So what am I going to do with negative? I'm going to flip the graph, flip the purple color graph over. So I have a y against x. So now my graph looks like this. Okay, so this is the shape that I'm going to use to solve questions B. Therefore, my answer would be, well, because the question is asking for y against x graph for a range in between 0 until 2 lambda, therefore the graph would look like this. So this is my y in terms of cm, my x in cm. The graph, the shape that I'm going to use is the shape in the step number 3 where my graph starts from maximum amplitude. So 1 cycle and then 2 cycle. So it stops at here. So the last thing, I'm going to label it. This is a 5, 0, negative 5. Okay, so my lambda, just now my lambda is 4 cm. Okay, my lambda is 4 cm. So here, I'm going to label it as 4. Here, I'm going to label it as x. Right? So 1 cycle, 2 cycle. Done. That is the answer for questions B. Okay, answer for questions B. And of course, if you know how to straight away, how to get the final answer, of course, you can proceed with the final answer. Okay, saya cuma tunjuk kamu step 1, step 2, step 3, so that you can see the difference. What happens if you have a graph with initial phase angle? Then you shift the axis. And what happens if you have a negative sign in front of the trigo function? Then you flip the graph over. Kalau Anda tengok equations, Anda terus tahu final answer, boleh saja terus sketch graph dalam warna hitam ini in your exam. That is fine. Alright? So I'm just showing you step by step so that you know what happens. Okay, what happens and how to obtain the final shape. Untuk orang yang tak tahu shape final ini, memang Anda kena buat step by step baru Anda boleh nampak. Step 1, you know the basic shape first. You sketch the basic shape first, which is a sine shape. Okay, the sine function. And then after that, you check whether there's an initial phase angle or not. If it is, then you see how are you going to shift the y-axis. So in this case, I shift my y-axis. So original y-axis is here. Okay, this is original y-axis. So I shift it to a new position. And then I add in the graph. Okay, saya tambah part graph ini. So I add in this part. Therefore, now I know my graph start from negative amplitude. Okay, so I'm going to remove the original y-axis, and therefore I have a shape, okay, as shown in the purple color graph here, right? So this is an additional part that I add in after I shift the y-axis. And then after that, because of the negative sign, okay, so I flip the graph over. I flip the purple color graph. So I flip it over, and then I obtain the one in the red color. So kamu boleh nampak, I buat step by step di sini. Step asal, step 1, shape tanpa initial phase angle, tanpa negative sign. Step 2, with initial phase angle. Step 3, with a sign. And then I get the final answer. So final answer must be 2 cycle, because question say you must sketch for in between 0 until 2 lambda. Okay, for 0 until 2 lambda. Okay, so now I give you 5 minutes to write it down. Okay, I give you 5 minutes to write it down because this is quite a complicated questions actually. So 5 minit untuk kamu catat. Okay, boleh juga catat step 1, step 2, step 3 supaya anda faham. Okay, supaya anda faham. So if you think you understand these questions already, then you may try questions E. Okay, questions E again is very similar to this question. Okay, so questions E. So question C, again, you see it's very similar to your question C. So sketch a displacement against time graph. Against is asking for y against t graph. And you see, whenever questions ask you to sketch y against t graph, you will be given distance. Okay, so x is now equals to 1.5 lambda. And again, it's asking for in between 0 until 2t. So this is the important information. Okay, these are important informations from questions E. So x is equals to 1.5 lambda, and a lambda is equals to, I think our lambda is equals to, what is the values of lambda? Yeah. Yeah, let me check. Okay, we have lambda equals to 4. So our lambda is equals to 4 cm. Okay, based on questions 8. So x is then equals to 1.5 times 4, which is equals to 6. Okay, which is equals to 6. So now let us let us simplify the equations. So y is equals to 5 sine 2 pi t minus pi over 2x. So this is the original equations, the equations given in the main questions. And we have x now equals to 6 cm. So y is then equals to 5 sine 2 pi t minus pi over 2 times 6. So we have y equals to 5 sine 2 pi t minus 3 pi. Now this minus 3 pi, well, whenever you have a value that is equals to or greater than 2 pi, you can actually simplify it. Okay, this is actually equivalent to y equals to 5 sine 2 pi t minus pi. Okay, why I know it's minus pi? Because if you have a circle, okay, so this is a circle where we have here start from 0. This is your pi over 2. This is pi. This is negative pi over 2. This is for the first cycle. If the object keep moving, then this the origin is also equals to 2 pi. And then here would be 3 pi over 2, and here would be 3 pi. So actually, pi and 3 pi, both of them, they refers to the same position. Okay, they refers to the same position. So if you have a value that is greater than 2 pi, then you can actually simplify it. Okay, you can actually simplify it. So that is, okay, that is for the questions. Okay, that is that is equations that we're going to use in our graph. Okay, now I'm going to erase this one first. Let us see, how are we going to sketch the graph now? So we have a graph y equals to, we have an equations y equals to 5 sine 2 pi t minus pi. Again, it comes with initial phase angle, but now this question is slightly easier than the questions before. Why? Because now you have a questions without a negative sign in front of it. So you can skip step number 3. So if you don't know the shape, then you can do step by step again. So step 1, okay, step 1, we have a general shape for sine. Okay, we sketch the shape for y equals to a sine omega t. So this is y against t. You have a sine wave, so this is the shape. And then now you have a negative sign. So negative sign means you're going to shift the y-axis to the left. Okay, shift y-axis to left by pi. Okay, by pi. So means now you want to shift it to here. Okay, you want to shift it to here. So the new graph would be like this. Okay, the new shape would be like, okay, this is step number 2, where now we shift the y-axis already. So y equals to a sine omega t minus pi. So you shift it by pi. So you need to add the half cycle here. This is an additional half cycle that you added into the graph. Okay, so the initial graph, you still keep it, the initial shape. This is the initial shape. But now you shift the y-axis, therefore you add a additional pi radian here. Okay, additional half cycle here because of pi. So you have a y against t again. So I think that's all. Okay, that's it. Because there's no negative sign in front of equation, so you don't need to add a negative. You don't need to flip it over. So now the final answer would be, okay, the answer for y against t graph, where your t is in between 0 until 2 capital letter T, 2 times period. So this is the shape. This is the answer. So y against t, according to step 2, now my graph should go towards here. Okay, so this is 1 cycle, 2 cycle. Okay, 2 cycle. Wait, yeah, this graph a bit cacat. Let me redo it. So I have a y against t graph. So y is in terms of cm, t is in terms of second. So now this is the shape according to my step 2. So according to a questions, it's asking for 2t. So I need 2 cycle. So I add in 1 more cycle here. Done. That's it. The answer. Okay, that is the final answer. So label it. Okay, don't forget the label. So this is 5. This is 0. This is -5. So for 1 cycle is 4 cm. 2 cycle, is time. So period. Okay, 1 period is 1 second. So 2 cycle, 2 second. So that's it. Okay, that is the final answer. Okay, that is the final answer. So if you know the shape by just looking at the equation, then straight away you can proceed to answer. Actually, it's very simple because you have negative pi. So it means your object, your graph is start from 180 degree. Okay, kalau kamu tengok dalam bulatan. So if you have a cycle, okay, if you have a circle, so it just simply means now your graph, it will start at here, at this position, pi. Okay, so oscillate from pi. So if you keep oscillating, then it will move towards a negative direction. Remember, the oscillation is always move in the anti-clockwise direction. Okay, so it starts from pi, then it's actually moving downwards. That's why your graph is going down. Okay, that's why your graph is going down. So that is a idea. You can either shift the graph, you can either shift the y-axis, or you can use the method that I taught you in a simple harmonic motion. Okay, by looking at the circle. So if you start from a 0, if there's no initial phase angle, then you just have a normal sine graph. Then if you have a pi over 2, mean it start from a maximum amplitude. If you have a negative pi over 2, mean it start from negative amplitude. If you have pi, means it's going towards a negative direction. Okay, it's heading towards the negative direction. So that is how you do a shifting. Okay, that is how you do shifting in a function, in a graph. So now I give you a few minutes to write it down. The idea is very similar to question C. Okay, the idea is very similar to question C. So I give you until 3:55 to write it down. Then we will proceed to questions number 3. Last questions for today's section. Okay, 5 minit bagi kamu catat. Yes?
Jom.
Ya?
Kalau yang macam negatif 3 pi, dia
Aha.
kalau kita pusing balik yang macam ikut kitaran tu, dia
Aha.
jadi negatif pi.
Ya.
So kalau negatif 4 contohlah. Kalau negatif 4 pi jadi kosong kan?
Ya, jadi kosong.
Okay, tu. Okay.
Okay. Okay, so let's look at questions 3 and 4. Okay, just a very short and simple questions. So the most important things, the main focus today will be questions 2. Okay, questions 1 and 2. Questions 1 teach you how to interpret the equations, and questions 2 teach you how to sketch a graph for different situations. So now question number 3, a progressive wave is represented by equations y equals to 20 sine 150 pi t minus 1.8x. So again, whenever you're given an equations, always compare with general equations. Y equals to a sine omega t minus kx. Okay, minus kx. Now, if you look at this question, now you have different unit. Well, y is the displacement in cm, but now x is the distance in meter. So now you have two different units, which means your k and your a, okay, your lambda, they all have different unit. So t is in second. So calculate the wave velocity. So to calculate wave velocity, now the general equation is v equals to f lambda, because you're looking at wave, you're not looking at particles. So wave v equals to f lambda, you want to find out what is the values of f, you need omega, because f, omega, t, they are one family again. Okay, so I will keep mentioning this until you remember. So f, omega, t, they are one family. You want to find out what is the values of f? Of f, you need omega. So omega given, okay, by comparisons, omega is 150 pi radian per second. Omega at the same time is equals to 2 pi f. Okay, so which means 2 pi f is equals to 150 pi radian per second. So this is the equations that we have. All right, so f is then equals to, okay, f is equals to 75. Okay, 75 hertz. And then we need to lambda. Okay, lambda and k, they are one family. Okay, so by comparisons, we obtain k is equals to 1.8. Now, this 1.8 is not in cm, but it is m negative 1, because x is in meter. So k, it uses the units for x. Okay, it has the same unit as a distance as x. So k equals to 1.8 meter negative 1. And k at the same time is 2 pi over lambda. So combining these two, 2 pi over lambda is then equals to 1.8. Lambda is equals to 2 pi divided by 1.8 meter. So now you can sub it into the equations. So v is equals to 75 times 2 pi over 1.8. Therefore, you obtain 261.83 meter per second. Okay, not cm per second, but it is in meter per second, because x is in meter. Okay, because x is in meter. So that is your questions number 3. So questions number 3 just to shows you how to choose the unit, the right unit for the right variables, for different variables. So y is in cm, means your amplitude is 20 cm, but x is in terms of meter. Therefore, lambda is in meter. Okay, so this is just a very simple questions. 1 minute for you to write down. Then we will move on to questions number 4. Okay, forming an equation from graph. Then we are done for today's section. Okay, last question. So questions number 4. You're given a graph. Okay, the first things that you need to do, remember not just in this chapter. Okay, whenever you're given a graph, you look at the axis first. Okay, masalah pelajar yang paling besar sekali, sangat tak suka tengok exist. And then, sendiri cipta unit berlainan. So now you have a y against x graph. Y in terms of cm, x also in terms of cm. So figure above shows a displacement against distance graph after times t for a progressive wave which propagates to the left. Okay, to the left means in equation it should be a positive sign with a speed of 20 cm as -1. Determine the wave numbers. Wave number is k. Okay, wave number is k, and then frequency is f. So now you have a y against x graph. From y against x graph, the information that we can obtain from the graph is lambda. Okay, so if you look at this graph, now you have 1, 2, 3, 4 along the x-axis, but lambda it's located at 2. Okay, after one complete cycle. So given lambda is equals to 2 cm, from lambda I can then determine k, because k and lambda they are one family. So k equals to 2 pi over lambda, which is 2 pi over 2. It is then equals to, now 2 pi divided by 2, you have pi. Okay, so lambda is in terms of cm, so k is cm -1. Okay, k is a cm -1. Oh, sorry, this is, yeah, that's true. Okay, so we have a cm -1, 2 pi. So if you want to write it in terms of meter per second, as shown in the answer, then it will become just 100. Okay, you divide by 100. So that is your questions A. So now you have a lambda is in a 2 cm. How about frequency? So frequency, now we know V equals to F lambda. Given V is 20 cm per second, so I have 20 equals to frequency time lambda also in cm. Because my V is in cm, so lambda should be in cm. Therefore, F is equals to 10 hertz. Okay, 10 hertz. So cm cancel out, you're left with just a SI unit as -1. So as -1 is your hertz. So F is equals to 10 hertz. So that is questions A. Now you have K with numbers, you also have F, the frequency. So questions B, write expressions of displacement as a functions of X and T for the wave above. So now you want an expression for this progressive wave. So Y is equals to A sine omega t. Now, according to questions, the wave propagates to the left. Therefore, you're going to have a plus sign in your general equations. So y equals to a sine omega t plus kx, because your object is to the left. Okay, your wave is to the left. So if you still remember, okay, the things I told you at the beginning of this lesson, whenever you want to format equations, you need to make sure you have 3 constant variable. The values for 3 constant variable, which is a, omega, and also k. Okay, a, omega, and also k. So now let's see how I'm going to solve it. So according to the question, to the answer given here, this one it gives you in terms of meter, but we can do it in terms of cm. That is fine. Okay, just make sure you put a statement, a note after you form the equations. So now let's see how to form the equations. So based on the graph, I have amplitude which is equals to 6 cm. So A is equals to 6 cm. Okay, and then I need a omega. I don't have omega, but what I do have, I have frequency. So omega equals to 2 pi f. Okay, which is then equals to 2 pi times 10, which is equals to 20 pi radian per second. And then I need k. Okay, so k from questions A, it is equals to pi cm -1. Now that I have all of the informations, I just plug it into the general equation. So I have y equals to 6 sine 20 pi t plus pi x. Now, after you form equations, actually you should state there what is the unit. So the unit for y and x are in cm, and then t is in second. So this is what you should do after you form equations. All right. So in chapter 9, after you form equations, you should also state that what is the unit for x, what is the unit for t. So in this chapter, you need to state the unit for y, x, and t, 3 different variables, because these 3, they are unknown. Okay, and you don't know what is the value. It changes with time, it changes with distance, but what you do know is the distance, is the unit. Okay, it's the unit. And of course, if you want to write a in terms of meter, then you can say y is in meter and your x is in cm. Also can. It's all up to you. Okay, it depends on how you form the equations. So I think that's it. Okay, that's all for today. So after you write it down, if you have no questions, then you may leave the class.